Hi, I'm Sharifah. This presentation will briefly examine the sedimentary structure of a two-dimensional bedforms generated from unidirectional flow. The flow regime and the process that are responsible for forming this structure will be discussed. Last but not least, the depositional environment will be interpreted based on the information gathered. The feature responsible for the formation of two-dimensional bedforms is the migration of dunes and ripples, which led to production of cross-stratification. The transportation of small-sized sediment with low velocity produces ripple, while larger particle that is being transported with higher velocity produces dune. The difference between ripple and dune is the amplitude of the structure, where ripple have an amplitude which is less than 10 centimeters.
Hello everyone, I'm Paula and I'm going to talk about the process responsible for forming two-directional bed forms. These structures are formed by the migration of sediments from the stored side coupled with the fluid flow, causing the eroded sediments to climb up the less steep stored slope and are deposited at the crest. The crest becomes eventually unstable and the sediment avalanches down the lee side, forming cross-stratification. This process is shown on the next animation, where you can see that sediments are eroded from the stored side on the direction of fluid, and as they reach the crest, they are being deposited on the lee side of the dune or ripple. Now I'm going to pass you to Jana, who is going to explain how the flow regime affects 2D bed forms.
Hello everyone, I'm Jin Chen, and I'm going to give you a brief insight into the unidirectional flow regime, which would result in a two-dimensional bed form. The sedimentary structure produced by this regime will be asymmetric ripples and dunes, as mentioned by Sharifah, and their formation may be explained by the stability diagram. So, as you can see, the flow velocity and the sediment diameter are the two governing parameters to the sedimentary structure. And from this little animation, we can see as flow velocity increases, so that means the shear stress of the fluid is increasing, and the transportation of the sediments would result in the transformation from no movement to lower plane bed and eventually to ripples and dunes. The sediments that form these structures can be from a range of diameters and flow velocities, and of course, they are all from the lower flow regime. The naming of this sedimentary structure, ripple or dune, is dependent on the height of the structure. And additionally, as the next picture shows, the two-dimensional bed forms are typically out of phase with the surface wave. And now I'm going to pass on to Henry, who will be talking about the depositional environment.
Hi everyone, I'm going to talk about the depositional environment of unidirectional 2D bedform. 2D bedforms are very commonly formed in fluvial depositional environment and aeolian depositional environment, which is mainly desert. Now I'm going to talk about three main information of the depositional environment we can obtain from 2D bedform. The first information we can easily obtain from the unidirectional 2D bedform is the direction of flow. Unidirectional flow of current will mold the bed into a series of small asymmetrical bed forms called current ripples, and they have a gentle up current slope known as stall slope and a steeper down current slope known as lee slope. The direction of flow is from stall slope to lee slope. Therefore, 2D bed form asymmetry is generally representative of the direction of the predominant forcing flow on the sedimentary surface. The second information obtained is the grain size. As we can see from this graph, fine grains and low flow velocity is required to form straight crested ripples, whereas medium-sized grains and higher velocity is needed to form straight dunes. Therefore, we can conclude that fine to medium-sized grains are responsible in forming a 2D bed form. Information on grain size can be used to determine potential grain source. As an example, sandstone with fine to medium grain size is the most common source in forming 2D bed form in fluvial settings. The next thing we know from unidirectional 2D bed form is a strand of flow. Straight crested ripples only can form with a steady and low velocity flow. While higher flow velocity is needed in forming of straight crested dune, it still requires a least amount of floor strength in upper floor regime. Therefore, 2D bedform can be used as determining climatic conditions such as wind regime in desert at the time of formation. Generally, bedform analysis is performed in conjunction with cross-bedding analysis for a more complete picture of depositional environment. Thank you.